start.
They can join from there itself. So let me have a quick intro and agenda for this webinar. This is all about the Lambda architecture, and I believe the prerequisites and everything has been shared with you. A person who should have a fair understanding of the Hadoop and Spark, and of course, this trimming is very important part. And for this, the architecture Lambda is based on that, how the streaming is being done, what is the Lambda architecture, what is the advantage, and mainly we are using some application which in real time. This webinar will be taken by the Jyoti Ranjan, which is our one of the best friends and education partner. So Jyoti, I hope you're there. I guess for today, Jyoti will show you some onto the AWS cluster. Because of some issue, we cannot put the entire setup on AWS. So he will help you to run onto the local machine. Parallelly, he will help you to give you the AWS 16 node cluster, I believe, or some node. He will make you all these things ready. I will request you all the participants, once Jyoti will complete its slides, then you can come back and ask a question. Once Jyoti, you will complete your slide, you can go to the chat window and you can answer all the questions one by one.
Okay.
Fine.
Yeah.
Jyoti? Okay.
Yeah.
So yeah, thanks Jyoti, you can continue. Rest, I can see still many requests being there. Let me handle this. You can continue from your session. Take care. Thank you.
Thanks. Okay. Hello guys. Good evening. This is Jyoti Ranjan Patnaik. I have almost 7+ years of experience with Java, in Java mostly, and but I have been working on big data technologies. Started from MapReduce, Epic, and then Spark, Kafka. It has been 3 years mostly. So yeah. So today we are going to discuss Lambda architecture, and we will use Kafka, Spark, and Hadoop technologies to build a application. And at the end of at the end of this session, we have a demo also. And I prepared a very basic application just to demonstrate the idea how Lambda architecture works, and why we need this kind of architecture, and to like which kind of challenges we face in enterprises, corporate. So we will discuss it one by one. It's a very vast topic to be covered. Just like you can see the 3 technologies, and Hadoop is a technology stack. So it's very difficult to cover all the concepts within this 1.5 hour. But I will try to just to try to explain very important concepts of Kafka and Spark mostly. So let's go one by one. Okay, and hope you will enjoy it. And if any questions, just drop me there, and I will try to explain. I try to answer within the session, or if not possible, I will try after the session. Okay, I will make it possible. Okay, so let's start. So today's objective will be like a brief introduction of Lambda architecture, and what are the components of Lambda architecture, and which use case it solves. And after that, we will go through a bit of concepts of every component of that Lambda architecture. Kafka, like we have it publisher, we made a Kafka publisher, consumer is there, and we have Kafka and Sparse Trimming consumer also, and it's a like end-to-end application. You will see it's very basic though, because it's just for a demonstration purpose. And one thing is that we have AWS setup, but Hmm. I have AWS setup, EC2 instances setup of 5 node. You can see in my screen. So one is edge node and one name node and 3 data nodes. Uh, I have this setup, and in the cloud run manager also you can see the services are running. Services are running fine. But for this session, I will run my application locally, just to demonstrate the idea, just to demonstrate the concepts, explain the concepts. So, and after the session, if you are interested, then you can see it in AWS. You will get it in the application report in AWS. Okay. So coming back to the presentation that we have, the content. Okay, so um, okay, let's go through one by one. So first of all, like what is Lambda architecture? Okay. So this is, as I said, this is an architecture. So architecture are for solving the problems. Architecture are the solving the problems. So here, hello, can you mute yourself? Verma, can you mute yourself? You are not audible, and it's like the noise is also there. Okay, thank you. Okay, so pardon, gentlemen. So this is okay. So we were discussing this architecture, Lambda architecture, and which architecture are basically solving the problem. So which use case it solves, we will discuss in a few minutes. So basically, this Lambda architecture is, you can see it's a Lambda. So in Lambda, this upper part is something we have publisher, and publisher will publish what they will publish. They will publish messages or records to some system, some message queue system, and then from there the application bifurcates. One is streaming kind of, and another will be batch. So this basically this Lambda architecture. Here, in case of publisher, you can use Kafka publisher, or in any Java application or any other Python application, anything you can have. Here we have, here we are discussing like using Kafka publisher, and you can so publisher will publish the message to some message queue system. You can use Kafka, you can use AMPs, uh, any message queue system you can use. So here, because Kafka is most popular right now in the market, so we will discuss Kafka. And from Kafka, we have these two different applications made with the objective, two different objects, which fulfills two different types of objectives. One is streaming, another is batch. So in streaming application, you can use Sparse Trimming, you can use Kafka, also comes with Kafka Stream, you can use Kafka Stream also. So it basically depends on your use case, or it basically depends on your requirement. So which kind of streaming you should use. Okay, so here I'm showing Spark Streaming application. If you have a requirement of Kafka, your source is Kafka, and your destination is also Kafka. Your sync system is also Kafka. Then I would suggest to go to Kafka Stream. It has after 0.0.10 they have Kafka Stream. So Kafka to Kafka, it's a Kafka Stream you can use. Kafka to database, Kafka to any file system, you can use Spark Streaming, because one advantages of Sparse Streaming is like it is more mature than Kafka. Kafka Streaming, as far as Kafka Streaming concerned, and Sparse Streaming has various connectors. You can write complex logic in your Sparse Streaming application. Kafka stream is evolving. It's a very good infrastructure. Um but yes, so for streaming you should use here we are considering Sparse. And the another part is that batch consumer, like batch for a batch process. So it will batch means it will run on demand. It will run on demand basis, a nightly job or weekly job, monthly like that, and and there will be various purposes of this batch. So here we will use a combination of Kafka and Spark. We'll see in the code. So in the building application, because I am more comfortable with Java, so I have made the application in Java. You can make it using Scala also, and if you're comfortable in Python, you can also make it Python also. So there is no constraints. I have built it in Java. So we will go to the code and we will do the application. Okay. So moving to the next slide. So why we are using this Lambda architecture? Like, what's the use case it solves? Uh, so basically, if you see our use case is like it's a very common in nowadays in enterprise, in corporate, in companies mostly. So what we need to build a scalable, fault tolerant, distributed data processing engine to handle massive amount of data. Okay. It has to be scalable. It has to be fault tolerant because you see it's on, if it is on Hadoop, Hadoop is on commodity hardware. Anytime it will fail, so we need to take care of that. It has to be scalable because we are processing so much of data, and we are processing so much data, and it should be distributed because we are handling lots of petabytes, terabytes of data. So if it is distributed, then then it will take less time. So and one more requirement that the engine must be flexible enough to store raw data to allow for exploratory analysis, as well as provides the platform giving business analysts meaningful data for faster response time. That means here it's a complex system because we need to query on ad hoc basis, like data scientist guys or business analysts, they want to query the data if, on the near real time data they want to query. If it's your use case matches this kind of requirement, that you need to have near real time system, so that you will query like kind of in near real time you can have kind of like top case sales or top orders of today on the day basis. So this kind of requirement. Uh, so here you usually don't need to deal with all the data. Okay, so all the raw data you don't need to deal with that. You need filtered, you need little bit manipulate, not in the sense of manipulated, but it's meaningful kind of filtered data on that, or aggregated data on that. You are storing in some hive or some system, then you are querying on that data. So when we say we need a near real time or when you need a streaming kind of stuff, so there to make it faster response, we should deal with only meaningful data. And when we and also in that statement you can see that to store raw data to allow for exploratory analysis. So that means they want to store all the raw data as it is in some system, like it can be HDFS, it can be HBase, or it can be simple files, so that the downstream systems can take it, or they want it for analysis after some time. So one more reason to have this batch is actually in Kafka, the retention, Kafka stores messages. Okay, we will go through Kafka after some time, but if you know a little bit about Kafka, Kafka is this kind of distributed messaging system. That means it stores messages, but it, the message retention time is 168 hours or 7 days. You can configure it for you can put it like for 2 weeks or 1 month, but someday you need to clean it, right? Because new more data will come into the system, and you have to move it to disk or somewhere. Okay, so you have to move it to disk. So we need to take a backup of that data. So that requirement can be fulfilled by your batch process, your batch application. So if you see this diagram, now this publisher will publish the data to Kafka, and from Kafka, your streaming application. One second. Just give me a second. Okay, sorry guys. So now you guys can see my slide. Okay, so thing is that okay, so we were discussing. So now if you see this streaming application will take the data from Kafka, and it will run continuously because it's streaming, and this batch application will just run on demand basis. It will take the data from Kafka and store it somewhere. Okay, so that's why it has two bifurcates, and this and there will be one publisher at the top, and it makes this Lambda architecture. So this is actually Lambda architecture. So how it solves that Lambda architecture, as I discussed, this Lambda architecture actually originally proposed by Nathan Marks, as it combines batch and real-time component. Spark allows, and we consider Spark. Why Spark? Because Spark allows seamless integration of batch and stream processing. Why we Kafka? Kafka being high throughput distributed messaging system supports parallelism, multiple consumers, massive load of data, and also decouples data pipelines. That means it will load. It can handle lots of data, and also decouples data pipelines means like Kafka will act as its own standalone process, and you can have any consumer. Okay, so today it is Sparse Trimming, tomorrow it is Kafka Trimming, another day if you have one more component, normal Java or Scala application to consume the data, so you don't need to do any changes in Kafka. Like you can think of performance tuning perspective, but Kafka will be fitted in any this kind of use cases. So it's quite good. Okay. Okay, so what we are building means what we will show in the demo is that we have this Kafka publisher. Kafka publisher will take the data. It needs some source, right? To because it has to push the data, publish the data to Kafka. So it needs some data. So from where it will take the data. So here I am considering Twitter. So Twitter using Twitter API will get some data. Will get some tweets, and this Kafka publisher components. It's a Java component I have written. So it will publish the data to Kafka, Kafka broker. So Kafka it will, and from Kafka, my sparse trimming application, the sparse trimming application, that's also a bit in Java. So it's a Java component sparse trimming application will be there, which will consume that data, and it will store it will store in a hype table. this Hive table, I have made it within the application, but it is appending. It is in the appending mode. That means your data will get appended, and you can query that data in that program also. That means currently I'm just showing select star from that table to show the data, but you can have like select count star from this and all this aggregated SQL logic you can write. And in the future, if you want to have it, your Hive systems has to be external. So you there is a less changes. So you can make it external Hive backed by PostgreSQL or MySQL. And you can make it. You can take it forward this simple application to whatever your use case. So, this application will just give you some idea and like will give you just a kickstart. Okay, so and this batch side, in the batch side, I'm using both Kafka and Spark, and this Spark core, here mostly Spark core. So Kafka consumer will get the data from Kafka and give it to Spark core, like RDD system. It will create RDD system, and we will save it in some file. In this, today we will just I will put it in just local file, but tomorrow you can put in HDFS system. Just a little bit changes. Just you need to keep the configuration file in your class path or something, and just need to change the URL of it. So instead of file, it will be HDFS, and your file is stored in HDFS. Okay, so data you can put your data to HBase, Cassandra, anything you want. Okay. So let's go one by one of that what we are trying to build. Okay, one by one we will go through all the components: Kafka, Spark Streaming, Spark, Kafka Consumer, all those beautiful stuff. So let's talk about Kafka. So Kafka is a distributed messaging system. So Kafka is a distributed. One second. Okay. So Kafka is a distributed messaging system where this producer is a it basically messaging system. As it's a messaging system, that means there will be a publisher, there will be a subscriber. So here we will tell producer, consumer, all that stuff. So the publisher or producer will push some data to Kafka, and the Kafka and the consumers will take that data and will pull that data from the Kafka. Now, okay, so now this Kafka in the middle part, you can see you have written my topic partitions. So basically, Kafka is also a kind of follows master slave architecture. Also, it follows master slave architecture. And here, basically, inside the Kafka, the main server is called broker. So we have Kafka broker. Inside your Kafka machine, we have Kafka broker. You can have multiple Kafka broker. In a single machine also, you can have multiple Kafka broker. So in your single machine will also act as a Kafka cluster. Your single laptop can act as a Kafka cluster. So Kafka cluster is nothing but the number of brokers. You can have 5 node cluster. Each node will be a broker. You can have that kind of cluster, or you can have like in your one machine or in one node you can have multiple brokers. So Kafka cluster is nothing but number of brokers we have. Now inside it's like the brokers. So all this producer will publish the data to the this data will come inside the broker. So inside the broker, Kafka has concept called topic. So producer can publish the data to the topic. Okay, to producer knows, like producer has that information, like which to which topic it want to push the data. So we will see the Kafka producer code. There we will be able to, we are giving the which topic we were trying to push the data. So the messages are pushed by the producer or publisher to the Kafka topic. Now this topic can be present in multiple broker also. Okay, so it's not that one broker will have one topic or one broker will have multiple topic. So one topic can be present in 2-3 brokers also, and like another topic you can have multiple topic also. So another topic will be present in another 2 broker also. It can. Okay. So inside the topic for parallelism or to distribute the data, we have the concept called partition. Inside the topic, we will have partition. So when we create the topic, we give when we create the topic, we give like how many partitions we need, so that this producer, when publish the data, it will be distributed. The data will be distributed to different partitions, and there are many logic like to distribute how the data will be distributed to the partitions. You can think of like a kind of round robin fashion. Round robin fashion, it's a equal default. So in round robin fashion, your data will come to partition 1, then second data will come to partition 2, and then third record. Here data means your record. Okay, producer record. Producer record will come to partition 1, then producer record will come to partition 2, then 3, then again 1, then 2, so that your data or producer record will be more balanced. Now each topic has one or more partitions. We know now each partition stores the message or the record, producer record, at offset. So in the partition we have offsets like 0, 1, 2, 3. Each partition has its own offset, and this is very important concept, this offset in Kafka, because we will go into the consumer, or the consumer will get to know. Just give me a second. Okay. Okay. So you can see my slides. Okay. So basically, this partitions. Okay. So these offsets, um, the data stored in these offsets. Now, these offsets are important because this when consumer will read the data, it will read from that offsets. Okay, from a space, offset means positions. Okay, where position the data is record is there. So consumer manages uh, which from which offset it wants to read. So offset management in Kafka has been given to consumer. So consumer can read from beginning, from a position, specific position, or from the end, or so consumer. So if it is important, this offset is important because uh, if you think like your consumer is running today, but after some time the consumer crashed. Now you have read till 5, offset 5. Now when the consumer will start, it should start from 5. It should start reading from 5, else you will process the duplicate data. So this offset in Kafka, you need to manage, like you need to store somewhere in some metadata or in Zookeeper. In Zookeeper, here Zookeeper comes into picture to maintain the offset till which offset consumer has read. This information, this metadata, is stored in ensemble of Zookeeper. So you need to manage. The consumer will need to manage that from which offset it wants to do. Kafka has provided its direct stream, direct approach, where it recommends to use Zookeeper, like when you the consumer took the message to the record from the partition, and now it is there are two kinds of scenarios. Okay, so first scenario is that consumer uh, takes the data, takes the record from the partition, from the offset, and updates the Zookeeper. Okay, I have read the sixth offset. Then it starts processing, and if it fails somewhere, then when it again restarts, at that time already Zookeeper knows that it is at sixth position, so it will start from seventh. So that's a problem, because your sixth record is not actually processed; it's failed in between. So this that's called receiver-based approach, and the second approach is called direct approach, which says that first decide from which record, from which offset we want to read. Okay, so it's the sixth record I want to read, and you read your data, and after reading your complete, you update to Zookeeper. Okay, so sixth record I have already processed. So in between, if your consumer if consumer crashed, then uh, Zookeeper didn't get the information that you are already processed. So it will send the data again so that you will be able to process. So there are two approaches, and there are many scenarios, lots of scenario in Kafka context. You need to decide, like which requirements you have and how Kafka solves this problem. So it's a beautiful technology, but you need to check all the aspects of Kafka. Now the Kafka also comes with different flavor. Like Cloudera has its own Kafka, Cloudera Kafka. The basic is default is Apache Kafka. Then Hortonworks also Hortonworks Kafka, and there is Confluent. Confluent has its own version, Confluent Kafka. So we need to also see which Kafka version or which Kafka flavor satisfy your requirement. So it's kind of advanced topic. So you have to read, you have to beyond this discussion, beyond this discussion actually. So I'm just giving you a hint. So you can explore all those flavors of Kafka. Okay. So basically, producer publishing data to the topic, then you in the inside the partition, your messages are decided in the offsets, and the consumer in that offset. So you will see in the code also. Okay, so moving to the Kafka producer, a little bit more into the Kafka producer part, because we have a component on Kafka producer. So in the Kafka producer, the record or the message is called producer record. So now we are actually discussing a bit of internal, how producer works, how Kafka producer works. Okay, so this producer record, whatever record we get from, for example, from Twitter stream, it has mainly actually two mandatory parts, and we have three optional parts. Okay, so total five parts: topic, partition, timestamp, key. Right? Topic. So as I said, producer has to define which topic it wants to push its data. So it has to give the topic name and the mandatory second mandatory field is value. So value means your actual data, actual record. Now you can give more fine-grained information like partition. So you can have inside the topic, as we say in this machine, like in the slide, inside the topic we have partition. So we need to say Kafka publisher need to say is that it's optional, like which partition it wants to put its data. So here actually there are many like we can have custom partitioner, we can have there are different there are different kinds of strategy how your data, how your message, how your record will be pushed to a particular partition. This is based on like there are four kinds of strategy actually: direct, and one is round robin, and custom partitioner, like that. So it's there, and the timestamp, like where how when this record came, and the key. Using the key, actual key is a recommended field. Actually it's optional, but it's a recommended field, because using the key you can partition, you can push your data to a particular partition. So key is also important, but it's optional. Now this producer record sends producer record is pushed to the Kafka, uh, send the Kafka producer engine. Okay, and we'll see like how it is coming into the Kafka broker part. But before that, coming to Kafka broker, actually, it checks the properties like what's the broker URL. Your data is like your data how it is serialized. It's serialized like string serialization, like key values, like how your key is serialized, how your value is serialized. Value means your actually fluid data or data. Okay, so your record, you said record. So it will use the serializer, it will use the partitioner if any partitioner is given or key is mentioned. So accordingly, it will check the partitioner. Then it will get to know, okay, which to which partition in the topic, in the inside the Kafka broker, this message, this record will go. So after deciding that, it will push the data to the Kafka broker. Actual Kafka broker, inside the Kafka broker we have partitions, and inside partitions we have inside the partition we have these messages, this message offsets. Uh, okay, so you can have like batch also. Record batch is also the it's a combination of multiple messages. Okay, so now we have it. Then your this inside the this record metadata is actually it's a kind of metadata which record or which message is present in which partition or which broker, inside which broker, which partition. That address of each record is maintained in this record metadata. Okay, so this is Kafka producer or Kafka publisher. And second is second component we have Spark. Actually, as the, we have time constraints, so I am just touching the concepts in every technology we are using. So because it's just introductory session. So in this okay, so next component we are using, next technology we are using is Spark. So Spark, what is Spark is at high level. Every Spark actually uh, at high level, Spark is actually distributed programming language. It's a distributed programming language. And give me a second, just not able to see the slide. Second. Just pardon me 1 second. Okay, so now you guys are going to see the slides. Okay, so the next component is Spark. Spark is a distributed programming language. Inside the actually we have two kinds of I will say functions or something. Functions like we have transformations, we have actions. Okay, so basically at high level, every Spark application uh, consists of a driver program that runs the user's main function and executes various parallel operations in the cluster. The main abstraction Spark provides is a resilient distributed data set that we call RDD, which is a collection of elements partitioned across the nodes of the cluster that can be operated only parallel. So you can see the emails. Let's pause a bit because we need we just understand like the Spark basics. Most of you may or may not know. So I'll just give brief overview is that this you can see the image like Spark driver. The upper part is Spark driver, and this Spark driver, your job actually this Spark driver submits your job to the cluster, to cluster manager, Yarn or Mesos, Spark standalone, or local in local mode also you can run your Spark application. So this driver application, it's a process, it's a JVM process. It submits the job, Spark job, to the executor, to the cluster manager, and cluster manager then assigns it to the multiple executor as per your configurations, your cluster configuration, and inside the executor, your task get runs. So it's a master slave. It's also a master slave architecture. So the task run inside the executor. We have in Yarn, we have resource manager, node manager, so, your application master. So there are got many concepts. So I will not go into detail. You may be confused. So what I will say is that let's just understand what is RDD. RDD is just a main abstraction. It's, you can think of it as a distributed collection. So as a Java or Scala or any or programming language developer, so what we know is like collections. Every problem we think as to solve the problems we think in collection perspectives. Like we have list, map, set, asset in that perspective. But here in when we code in for Hadoop or Spark, we need to think in map reduce in map reduce way everything. So that thought process needs to be a bit of challenging and needs to be changed for a new who are newbie in this technology. So they want to just develop this thought process of everything to think in map reduce way. Okay, so uh, okay, so next concept this Spark has is called shared variable. So shared variable, these two kinds of shared variable in Spark: broadcast variable and accumulators. So broadcast variable is basically it's a read only thing. Why we need it? Because sometimes some variables or some resources we need every process needs, it's a common resource. So what we can do, we will put it in, we will declare it as a broadcast variable. So when we declare it broadcast variable, what actually happens is that the copy of that broadcast variable came into each machine, each node. The copy will be in the each node, so that when your task gets executed inside the executor, uh, at that time that copy will be used. It's a read only. You cannot modify. Cannot modify. So it's fine. It's fine because we are it's in every node. It's kind of data locality concept. So it's a read only. So it won't be a problem. It reduces your network movement, right? So because your data is a present and your data node or node inside the data in your node. Second thing is accumulator. Like accumulator is nothing but a kind of counter, but in a in distributed perspective. So it's a native native value or default is numeric type. Suppose numeric type. So you can only increase this accumulator. So instead of normal int count or something, you should use accumulator when you write Spark code. So accumulator, it's numeric, and you need to like add method you need to call, and you will increment the. Now, now let's think a bit, discuss about parallelism in Spark. Okay, so how parallelism work in Spark? So it's actually a combination of your partitions and executors. Then what is partition? Basically, in Spark, when your data is stored, like in form of RDD, or when RDD is created, when your RDD is created from a list or collection, so when you, at that time, your data is actually partitioned. You can mention like how many partitions you want also explicitly, but your data gets partitioned because we are thinking in a distributed environment. So everything, so we have partitions. Now, if you have one partition, your data has one partition, but you have multiple executors. You can see in the emails that you are seeing multiple executors are there, but you have only one partition. At that time also, the parallelism is one. It won't Parallelism will be one because you have only one partition. Even if you have multiple executors, it doesn't mean anything. It's just parallelism is one. So your program will not be that much faster. Okay. So if you have many multiple partitions, so you have 1 GB data, you have 4 or 8 partitions, but you have only one executor. So at that time also, your one executor, your task is running inside that executor. It will, as it has only one executor, then also your parallelism is slow. So your program is also will be slow. So you need to think like partitions. You need to consider both partitions, how many partitions are there, how many executors are there, to calculate the parallelism implementation. Okay, so as I said before, there are two kinds of functions or two kinds of processing we do with the data in Spark. One is action, another is transformation. So transformation is just uh, will be calculated. Okay, so it's a acyclic graph. It's just how your data will be calculated, and action is actually triggers your process. The transformation, there are two types of transformation. So one is your narrow transformation, another is wide transformation. So in narrow transformations, we have like a narrow transformation means like partition your data move from one partition, like from same partition to it's just one whatever data present in the one partition, all the data moves to this another the same partition, just single wave move. Okay, uh, but in wide transformation is actually the data presence in one partition gets shuffled and moved to different partitions. Okay, so let's say wide reduced by key, there are the shuffle operations we do. Those are it's a cost, the expensive operations. Wide transformations are expensive operations. Okay, so and because as I said, the action triggers the job. Actual action triggers the process or calculation. So it's based on lazy evaluation basis. Now, just think that we have a acyclic graph, a long graph. Okay, and uh, we process the data and we process the data one by one. The node of that one by one node of that acyclic graph. But somewhere your data, your application get crashed. So at that time, what it will do, it will start again from the beginning of the node, and it will again start processing all the logic and everything, all the nodes you have in the present in acyclic graph. So it will take some time. Uh, So to save that time, to make it more performance, better performance, so Spark provides concepts of persisting your RDD. Spark, in a Spark, everything is actually RDD. At the end, it's all RDD, resident distributed data set. So there are two kinds of persistence. One is persist and one is CAS. Yes, so we have different types of persistence level. So memory inside the memory, because everything in Sparka is on inside the memory, inside your RAM. So memory inside the memory, also memory serialized. Your data will be serialized and presented in memory. So you have memory and disk, deserialized manner, and also memory and disk serialized. So there are different types of persistence. The default is in memory only. So if you write the cache, so it will store in the default that memory only. Inside the RTD will be persisted inside your memory, the RAM. And if you use the persist, then you can give your persistence mode. That says disk or memory, serialized, deserialized, all this permission. So you can go through the Spark programming guide. There, it's a beautiful. They've explained all these concepts. I'm just giving the overview. Give me a second. Just okay. So you guys can see my screen. So the next is sparse trimming. So basically, if you understand the Spark core well, like RDD, so if you can write program in Spark core on using RDD, then sparse trimming is actually nothing but your collection of RDD. It's a batch process of RDD, and there are many scenarios in sparse trimming, and there are many complex scenarios also in sparse trimming. So in this session, it's like kind of beyond the scope of this session. So what I will do is just I'm giving the basic of sparse trimming. So sparse trimming receives the live input data streams and divides the data into batches, different multiple batches, which are then processed by the Spark engine to generate the final stream of results in batches. So you can see there are multiple batches. Each batch consists of multiple RDD. Okay. So as in Spark 4, we have RDD, the basics abstraction. Here we have discretized stream, that is D stream. So sparse trimming provides a high-level abstraction for discretized stream or D stream, which represents a continuous stream of data. These streams can be created either from input data stream from sources such as Kafka, Flume, Kinesis, Amazon Kinesis, or by applying high-level operations on other D streams. Also, you can have console producer also. So from the console also can be a source. Um, so these Kafka Flume Kinesis are advanced sources. The basic sources are like file system or your one socket, from a socket you are getting so your data. So these are basic and these are some Kafka film analysis or some advanced sources. So here we will use the advanced sources Kafka. We will see the code itself. So internally a D stream is represented as a sequence of RDD. So it's all sequence of RDD. We get some input data stream. Sparse trimming will convert to multiple batches. Inside the multiple batches we have blocks. Actually inside the block we have this RDD. So this in Spark programming guide, you will in the Spark streaming, you will get all the knowledge there. Here we will see in the demo, in the code, we will see how the streaming is working. I will show you an example also. Okay, so I think we should go to the demo. Has been already 8, just one more left, so you will go to the demo quickly. Okay. Okay. So in the demo, let's just before going to the demo, just let's see. Okay, so let's see this. Just keep it in mind that this diagram. Okay, Kafka publisher will get the data from Twitter. Kafka publisher then push the data to Kafka. Then from Kafka, we have Sparse Trimming application as a consumer. We will run another consumer also. We will have console producer to just validate the data, what the Sparse Trimming is processing is correct or not. So we will see in also in console, and also we have this batch process that will run on demand basis and it will be executed. It will just save the data in some file system for the time. So in Sparse Trimming, we'll store the data in Hive and do some select star form. You can do select count star, any SQL you want to run, and those batch process. So we have three components here: publisher, streaming, batch. So in the code also, if you see, I'm opening Eclipse. I'm using. You can use IntelliJ. That's also very good nowadays. ID. You can introduce IntelliJ. Okay, so we have publisher here. The publisher application I have written, and very simple application to make it, because now we are learning. So because so we will just understand the basic concepts well. Then we can write more complex property. Okay, so I will go through, but before that I will show you just the application. Then we will go going through the code text tag. Then I have this Spark stream consumer, Spark stream consumer, and then I have this batch consumer. Just okay. So now we will before that we need to set up. We need to set up. What we need to set up? We need to set up the Kafka. So Kafka needs Zookeeper first. First, it needs to run the Zookeeper because their offsets are getting managed. So Kafka needs Zookeeper first. So we will start the Zookeeper in this window. So how actually we came to here is that you can download Apache Kafka from websites. Download Apache Kafka. Just one tar file would be there. 110 is the latest one. I think I have downloaded 110 only. So you can have this Kafka download, primary download. Inside that, we need to extract it. Kafka 101. Okay. And so Even later we can provide the document also if you are interested to support. So we have this. I have this Linux machine, Ubuntu machine. So here I am starting the Zookeeper. To start the Zookeeper, it needs Zookeeper properties file. So inside, like being so the Zookeeper properties file is inside the config directory. So after starting, just start the Zookeeper server. So binding the port 2181. You can see the 2181 is for Zookeeper. It's started. Then we need to start the Kafka broker, the Kafka server, or we call it broker. So we need to start Kafka broker. So it needs server.properties. Here server.properties. If you have one machine setup, then you will have one server.properties. If you have cluster, then you need to have multiple server.properties. Each server.property will contain the information for each machine, one machine. Okay. So here I have just one machine setup, so that's why it's not setup. So I'm starting the Kafka server using the server properties. Okay, cool. Loading offsets, it's trying to load like till when it reads the Zookeeper, like Zookeeper stores right in the offsets. So setting Zookeeper and getting till when it is offset is loaded, everything is going to load, everything is done. Let's see, is there any topic is there or not? To list the topic, so we have Zookeeper started, we have Kafka server started. Then we need to see is there any topic present or not? Then we'll create a topic. So this list Zookeeper and your 2181 where your Zookeeper is running. So another window here. This will list uh, okay, and okay, and in the publisher here. So here I will check with the Kafka topics using Kafka topics.sh. We can see like is there any topic already created or not. Okay, so Lambda demo is already created, so we don't need to create again. So if you want to create, you can use this command, the Kafka topics.sh create Zookeeper, then your Zookeeper host port, then how many replications you want and how many partitions inside the topic you want and what's the topic name. Okay, so you can give this. Instead test I have given in the demo. And let's start this console producer also. This console producer, that means this is another consumer that Kafka provides default. We will have our own consumer. So just to validate, we will have two consumers. One is console consumer, and another we will have our application, okay? Our Java application. So Kafka console consumer. So here I have given that from beginning it will show all the topics, all the messages present in this topic, Lambda demo topic. Let's start here. This is for the consumer. It is showing some data. Why it is showing some data? Because I have already run the publisher. my data, my Twitter data is already some data are present in the publisher. I can create a new topic also. Just for demo purpose, I'm using the same topic. So this all these data are already in the Kafka broker. So it won't create any problem. So what we'll do, this is the Kafka. So now this publisher part. So the publisher, I have this Java project I have, right? So for this Java project, this class, this project, I have created one fat jar. Okay. So that you can directly deploy this fat jar in your cluster and it will run. Okay. So I will call this fat jar Java-jar, my fat jar. Then here in the code I have written, in the main method, main function I have written, if there is no argument, it will just check what is the trending hashtag trending. So all the tweets having hashtag trending. If there is something if you are providing in the argument, then it will search that. So you can go for either, no problem. You can try for Salman Khan, you can try for news, anything you can. So any trending or IPL, IPL is going on. Let's see IPL. So if I will start this publisher, I will see some this publisher will get the data from the Twitter, all the tweets having IPL hashtag, and it will push to the Kafka broker, which communicates with the zookeeper, and it will have in sync with the zookeeper. And this console consumer I have, Kafka console consumer, there this data will be seen. These messages will be seen. So let's just see this. Let's see if there is some data. We go to console consumer. Let's see. Just so that new data will come. Hopefully, you guys must be thinking here. Okay, yeah. So I will take one. Let's and I will open JSON editor. I have so all tweets are JSON. The Twitter response. So using this editor. Let's see like what's the data it has. Yes. Okay, so okay, cool. So April 8, 14 is the time. Okay. Okay, so did Twitter and text is did Twitter shadow ban take was something trending via the media. Okay, entities. Okay, somehow it's taking trending. Okay, check that. Maybe it's okay. So it's basically taking the trending hashtag trending. Okay. Okay, so there is that. I'm just showing the demo. Okay. So it's trending. It's checking the trending. All the tweets having trending. No, the IPL maybe some logical. Okay. Anyways, So in the consumer, we are seeing this data. Now we will start uh, our application. Okay, our streaming application. So here I have it here. In the streaming, as I have told you earlier, in the streaming actually we don't need all the data. There's so many data here. You can see there's so many things, so many JSON entities are there. Basically tweet JSON consists of your tweets and the user, and another is entities. Okay, uh, it is entity. So I don't need so much for the demo purpose or the sample application. I'm just more interested in the text, and when it is created somehow like that. Okay, so basically I'm choosing four fields: created art, text, source, like that, just to give you a demo, just to give you a feel. Okay, so if I am starting this is my consumer. This is my stream consumer. So in the Lambda, it's the left part, the left button. So in the consumer, let's start that. This also I can make it a fat and I can run. Just not to make it confusion at the console level. So in the terminal, so I'm just running it on console. Here, okay, so you can see the data are coming created, but there is few data only created: ID, IDSTR, text. You don't have much because I have given the object as only three, four fields. And what it does is actually it stores in Hive table. So many data is actually getting processed. So what I will do, I will stop this consumer and let's see like what it did. Stop this consumer. It can run like continuously till my system gets out of memory. It will go. Okay, let's see. So what I did in that Sparse Trimming application is that I have created one Hive table. I have created one Hive table and I have stored all those meaningful information created at land, language, and source, and text, meaningful information in that, so that one can query this Hive table. In business analyst or data scientist guy or some analysis, they can do analysis on that Hive table. So it is very easy. It's better to store it some kind of Hive to make it like ad hoc queries, because later you can use your Cloudera U, or you can store in Impala or something. You can use you can connect to this Hive table and you can run ad hoc queries. So this logic has been written inside this. This is one, and the last part is that the right button, that's the on demand basis, the batch consumer, our batch consumer. What it does, it will just take the data from the Kafka broker, and it will save it somewhere. Like you can put it in HBase, you can put it in HDFS, you can put it in, again in Hive also on some level. Not Hive is not right choice. You can put it in HBase, you can put it in Cassandra or in HDFS, so that later you can use it. Here I am just using file system, local file system. With a bit modification, configuration changes, you can put it in HDFS also. Okay, so here what it will do, it will create here in this location. Let me show you the code. Here I have saved it in inside the output directory of my workspace, and Kafka BKP underscore the start time I have given. So that always it will create a new directory. It won't throw the directories already exist, that kind of error. Okay, so Kafka BKP I have given because I just need to back off the whatever data present, message present inside the Kafka broker. Because after the retention policies, these messages will be destroyed or will be gone. So this is one on demand. It is not like continuous process as your sparse trimming application will keep on running. So it will just run. It will check the last offset it has already processed. It will take from that last offset and it will start processing and put it in that output directly. So I will show you this output. There is output directory, but there is no file. There is no directory inside it. Refresh it. Okay. So there is no directory. It's when this application will run, it will create, it will do Spark, it will run Spark job, and it will create some directory, part files inside that output. So these are the offsets. As you can see, 193, 194, 192 offsets. This offsets it is processing. So this offset it is processing and okay. So now the process is already completed. I can see. I will see. I will refresh. Okay, some files are there. Let's see what's the data present. There is a Kafka BKB. So you can see all this data, whatever the like inside the broker, the long data, the long text, hold to it. Because here I don't want to filter, I don't want to manipulate the data, I just want to back off of the Kafka. So that's why it is batch process. It will run nightly basis or in like one weekly basis. So it will dump all the data from Kafka to another system, another destination here and to different file system. So it will generate these part files, and inside the part files, all these tweets are present. Okay. So actually, this is how all this the Lambda architecture, the application inside the Lambda architecture. Now we have exactly 10 minutes, so I will go through code to go through the code a bit, so that we'll be able to understand how this magic happens. Actually, nothing is magic. So let's reveal the magic. So this is the publisher first. Okay, Lambda, the upper part is publisher. It will publish the data to the Kafka broker. So this Kafka broker, let's see. Okay, let's first go to the main method. I have written in Java. You can write in Scala if you are comfortable. You can write in Python. So here it's taking the trending first of all. So the trending hashtag trending, and then I think I need to pass through hyphen D option. That's why it is not taking. Anyways, so that's why it is taking the trending. We can program is correct, but the I passed is wrong. Anyways, it's fine. So this is the trending data we have. Now it's calling the run producer. The run producer, this is the method, and we are using Kafka producer for this. You can write your own Java producer, but Kafka has its own producer. Let's use that. Why to invent the wheel again? So Kafka producer, we have this create producer. We're calling the create producer. In the create producer, we need to keep some properties. Like what's the server? Server is like what's the URL of the broker? So localhost 9092 is the broker. 9092 is the port. Then the client ID. Client ID is that this machine, this Eclipse, this program where it is running. Like that to distinguish, there can be many consumers the many clients. So the to just to distinguish, I gave it a name Lambda producer. You can give it anything. Now this key serializer and value serializer. So in producer record, if you remember, in that image we have given like serializer key. What's the inside the record we have key, we have topic, we have there. Let's go through. Let's go through that image. So, Yes. So this producer record, right? So it's inside that if there is a topic, there is value. These two are mandatory. So I've given the kind of these two are mandatory. Then partition, timestamp, key. Key value are there. So we need to, and later we need serializer. That's why we are defining like key. What's the key serializer and what's the value serializer. So it will serialize the data, then push to the broker. At the consumer level, it will be deserialized and will be processed. That's why serializer is very important concept in distributed programming. And we need to create this Kafka producer, having like topic and value mostly. So this is the props. Now to connect to the Twitter, we need to give authentication, some authorization. Okay, so let's. So after creating the producer, I have mentioned one blocking queue. Blocking queue is multi-threading. In blocking queue is a concept used in multi-threading, where actually we define the limit like 10,000. So it won't take more than 10,000 element. It will block that insertion. Also, it will if it is zero, then it will not pull the data. This pull the data from the zero. The if the size is zero, then it will not pull the data. So it will block that also. So it will block at both the end. This so that's why this data structure is called blocking queue, and it's a linked blocking queue. So it's like all the queue can be implemented linked list or a list. You guys learned in college. So so 10,000 element it will contain that queue. You can give an amount for your requirement. Then this is the endpoint, status filter endpoint. This endpoint is actually will be used while communicating with the Twitter. Okay, so endpoint. So we need to the status filter endpoint is you can see is a Twitter HBC package. Okay, so before that I should actually explain in the pom.xml what are the dependencies we need for this application. Okay. Quickly just go through. So dependencies, uh, Kafka client. Kafka client will contain two actually packages. One is Kafka consumer, another is Kafka producer. So if you are writing Kafka consumer also, you need this package. You need this jar dependency. If you are writing Kafka producer or consumer also, you need this. Kafka clients have both. Both are Kafka's clients. Okay. So next is Twitter. Twitter, this HBC core package is there. HBC for Twitter get get the Twitter data. This log4j, SL4j, you can use that and test it also. So importantly, these two. You don't need any Spark, you don't need any Hadoop, nothing. So it's just Kafka and Twitter. I made this simple application to understand better. I do not want to make things complex. That's the objective. So then you can have some track items. So if you are giving multiple track items separated by comma, it will just separate. It will just have all the elements, and it will give as a list to the Twitter. Okay, give me these track items. So my program satisfies multiple track items. Now this client. So here I need to give like host stream host is nothing but your stream.twitter.com. So this one and this endpoint. What I have generated here status filter endpoint to hand actually to connect to the like APIs, right? So it's kind of API. So endpoints are concept is there. Authentication. This authentication auth, what you need to do is that you need to log into the Sparse to the Twitter development portal. There you need to create one application. There you will there will be given one consumer key. Let me show you. So one consumer key, consumer secret key, token, and secret. These four elements you want. So you can go to this Twitter development portal and you can create one application. You will get these four information. Then you need to connect. So after that, stream delimited processor. We need to pass the queue, then build, then client.connect will get the data, and so this whatever data we will get, it is actually our producer record. Kafka producer as the producer record, as in the images, this Kafka producer record. So this is Kafka producer record. So in the producer record, I need to know topic and value. These two are important. You can have more things also. So producer record, then topic. You need to keep the topic name. Then this is actually your partition. Uh, two string message, integer two string message. Okay, this is the partition. So not actually this is the this is the partition, or you can use as a so you can use a not partition is actually your key. This is your key. So what I have used is that 0 to 1000, right? So 0 to 1000 messages I am taking from the queue. It's the limit is 10,000. I'm taking 1,000 only, and I'm giving like 0, 1, 2, 3 as key to the each message, so that it will be partitioned well inside the Kafka processor. So this is the key, and the queue.tech is the actual your tweet. So this is the actual queue.tech is the actual. Actually, we are running out of time. So producer and then this producer and record. So at that time, it will push the data to the Kafka. And this client stop. So it will push the data to the Kafka, and what it will do, it will store inside the Kafka broker. So this is your publisher code. Similarly, we have stream consumer. Just quickly, we have very less time. So this is consumer. So consumer, this is Sparse Trimming application, the left bottom side of Lambda. Okay, so here we are giving Spark conf. Spark conf is Java streaming context. Like this duration is your batch interval. Batch interval is 2 seconds. Every 2000 milliseconds or 2 seconds. You are consuming a broker, right? So you need to mention the broker URL. Then topic from to which you are consuming. Then you can give multiple topic also in this way. And second, after that, there's the Kafka parameters. What's the what is the list of brokers? Like localhost 9092, or you have 9093, 9094, like that. You can pass multiple broker also. You can read that. So after that, this logic comes into picture, like to process the data. Kafka utils is the package. So here I am using Spark. What are the dependencies I use? I use your, because here Spark comes into picture. So I have Spark core, Spark streaming. So here I have Spark core, Spark yarn, Spark SQL, because I will store it in Hive. That's why Spark SQL and Spark Hive. In Spark streaming package, and the Kafka version of Spark streaming Kafka. This is different Kafka. Apache Kafka is different. Cloudera Kafka is different. From it's different. So I am using Sparse Trimming version of Kafka 08 version, and I need Kafka client because it's also a client. Twitter 4j, I need to parse that data, so that's why I need Twitter 4j to parse the tweet, and I need some meaningful. So I need to parse the JSON object, so that's why I need Google. I'm using Google JSON. So go through the code. So here I'm just all the messages. Okay. So Kafka utils take the data from the create direct stream is actually direct approach. I have explained two types of approach: receiver based approach and direct based approach. And I have explained also like which approach the receiver what's the problem in the receiver based approach. So here direct approach is the advanced one, is the better one. So we are using direct approach. And using the direct approach, we are getting the data from Kafka broker. And once we get the data, then we are using our logic. So what we are doing, we are just we need the uh, we have topic and your message tweet. Hmm. So we need only tweet, not the topic. So that's why we have people two, and the second of that tuple. So here Scala tuple is being used. So we have these lines contains only the tweets. So we are just printing here first of all. Then we are going through each tweet, and here we need to our objective is that we need to store meaningful data in Hive so that we can query that. Okay, so that's the objective here. So we are using Spark session, which is two after in Spark 2. It's a feature of Spark 2. So here we are uh, okay. So what we are doing, we're creating the Spark session object. Then we are creating for each RDD we get the tweet object, because I have declared like how tweet is my one Pojo class, data setter class. I'm interested in text created at source line, so only those data will be persistent. Okay, and I have just removed few data because it's for demo purpose only. Okay, so that's why this is how we map our data to the tweet object. Tweet object is in Java object. Okay. So here actually I'm passing the tweet JSON to my tweet object and returning. In that tweet object, I'm using that RDD, and which tweet class that will act as a schema. It will create a data frame. Data frame is data set of row in Spark 2, and I am just writing that data frame in the append mode and creating as a table Twitter. So once it will create a Twitter, the data will be appended continuously in Sparse Trimming mode. So that's why we have this kind of table. I think okay, because when I was running in Sparse Trimming, there I have shown one table. It will append in that Hive table, and you can query anything. Here I'm just doing select star from Twitter. You can have any analytic SQL query, and you can have your result. Okay, you can have this Twitter external table also. Bit of configuration needed, but this is basic, so I'm not showing here. The last is that batch process. It's straightforward. You need to take the data from Kafka broker, give it to the Spark, and Spark will store it anywhere. So similarly, Kafka consumer needs some property. The Kafka consumer needs some property. Uh, so after the Kafka consumer, it's a bit of little bit. What it does is actually taking the data from the Kafka. Let's go to the main menu. Okay, main method calls the run consumer. The run consumer creates the consumer of the consumer, and it subscribes to that topic. I have defined the minimum batch size 5 to just to demonstrate. Like I don't, you can have 5,000 also. Just to think that small size. You can have many. So basically, what my logic is, that consumer record that the client side, the consumer record, like producer at the producer level, we have producer record. In the consumer, we have consumer record. It will poll. It will poll thousand. It will poll in every 1 second, and what it will do, it will get the record, and it will add in a buffer, because we will take one record and then we will persist. So it's a heavy process, right? One by one processing the data. So it will be heavy. So what I will do, I will do it in batch wise. So I will create one buffer, and after that buffer, when the buffer will fill, that buffer will be dumped to downstream system. Okay, so I'm just creating that buffer, and that buffer I just is a list of value, the Twitter value, and I'm just printing it or the key value outside. Then just put a condition like when this application will be stopped, when that buffer size is greater than this minimum batch size. They're giving just 5 to just give you a demo. Okay. So just 5 basis. So you can have a 5,000, 50,000 or 500K you can give also. So that as per your RAM in your cluster. So the buffer size, so when this buffer size is uh, greater than buffer size is greater than minimum batch size, then it's time to close it. So we are storing it. Then we are calling the store buffer. Store is nothing but it's uh, giving giving the list to the Spark. The Spark job is actually storing it in your this output directory. After storing to the file directory, then we need to consumer commit. So commit is that to tell that to Zookeeper, okay, so this much data is I have already stored. Okay, next time you don't send me this offset data, I have already stored it. Then I need to clear the buffer. Then I will come out of that loop because I am just doing while proof. It's infinity loop, but when this condition will be satisfied, at that time this everything will happen and it will be ready to get closed. So that's why it was the tweets are being stored in that file system and it was getting closed at that time. Okay, so I think I have shown. I've explained all the components of uh, I've explained all the components of Lambda architecture, what use case it is solving, how it is solving, just to give you a demo and walk through the code. You must have got some few overview idea because 1.5 hours is not enough for all these vast technologies. So just overall thing that I have explained, there are lot many things to discuss, there are lot many things to know. There are many scenarios Kafka solves. There are many issues with the Kafka also. So it depends on your use case. So you need to study. You need to go through the Kafka documentation and start documentation. Okay, you can contact us with this slide with all these informations. And any questions you have, you can. So let me see if you have any question. Mm, Okay, cool. I don't have any questions, Rupan. Thanks. Okay, it's good now. Okay, cool. Yeah, Verma, you there?
Yes, Samya. So, guys, I believe you have gone through all the things. Jyoti, have you gone through the AWS part?
Yes, yes. Initially,
So,
I have said.
we have given the overview of this part. So, soon we will come with the AWS server, which we have. And Jyoti will help you into this part as well. And most probably the next session will be soon. We'll update you. Most of the participants could not take it, so we'll make this video live. Jyoti, you can go to the website where the webinar page is there. You can go and download this session from there. Jyoti, can you go to the website?
Okay, so we can.
Prwatech.in.
Uh, uh, okay, this record thing we can do it later also, right? Or you
Yeah,
want
they
to do it
can
now?
yeah, open the website. No, no, just go to the website.
Go to webinar website. I'm
Go to
in the
website Prwatech.in.
Okay, okay. Yes. Yeah. Okay.
Yeah, go to the services.
Yeah.
Services is there.
Yeah.
Services we have. Yeah, click on that. Yeah, click on. Yeah, there's a. Go to the services. Services. Go to the. Click on the service. Just stay there.
Yeah.
Again, click on the service.
Again. Okay.
Yeah, there's a upcoming webinar is option is there, right?
Okay. Upcoming webinar. Okay.
Right. Here are the links which you have registered this part. So from here you can download this. We'll put a one link. Through this you can download this all the session webinar. If you have still any doubts and query, they can you can contact to us onto the most of the students are already registered at I guess they're ping onto the WhatsApp. Just open the contact us
Yeah.
form. Yep. Yep. So these are the source. If you have still any doubts and query, and you can write to us and the same number 8147111254. This is the WhatsApp. The support team will help you if anything you want. And yet we are coming with a multiple webinar every weekends. So we'll keep updating this post onto the same page. Upcoming webinar, you can enroll yourself and get more all the things ready. Our effort towards to get and to give you more productive session related to the production, use cases, troubleshooting, performance, which is the major challenge that learner today they are facing. So our focus to make you into that label. So when you're going for any interviews, for not for the interviews, for the learning and understanding, you should be the you should be have that much potential. And yes, the knowledge wise that you can work onto this. So my team and with my all the scope trainer will be coming with the multiple sessions soon. I request you again, this is all a limited seats. Many of the students not able to make it because of the bandwidth. It's only 101. We can make it. We are looking to increase this bandwidth. But again, I said, it's come first service. And rest, those who are not able to make it from next session, we will make it live to our website, not on the website, onto the Facebook page, so through which you can take this webinar session again. So thanks a lot. You got your precious time to be the part of this session and hope you learned today. And still the things is not yet. We are looking forward to give you the service from our end. So thanks Jyoti to be for this your time and your effort. And by tomorrow we'll be coming with this all the video and we'll generate the link to the mail which you have registered. Thanks a lot for your time, guys. Happy weekends. Hope to see you in the next session. Thank you.
Thank you, guys. Bye bye. Good night.